Hi friends, welcome back. Today we're talking about perpendicular bisectors in triangles. And it's exactly what it sounds like, a perpendicular line. And remember, perpendicular creates right angles. That's the abbreviation or the symbol for perpendicular. Bisectors means it cuts something in half, right? So it's exactly how it sounds. We're going to create a line that cuts something exactly in half, but that has a 90-degree angle. So let's take a look at how that looks with triangles. All right, the easiest way to demonstrate this is, well, let's back up and say we have three types of triangles. We have right, obtuse, and acute. And so I'm going to start with our acute triangle here. And the best way to do this is to find the exact middle here is to fold this over like this. And if I fold it over, not only am I finding the exact middle, but I'm also creating a 90-degree angle. So you'll see that I'm going to fold that over just like this. Okay, I'm going to do that for all these sides here. So we've got this guy right here. I'm going to fold that one over exactly in half, kablam. And then we got one more side here. I'm going to crease those really nice so that you can see that. Okay, and then we've got this other side where I make the corners meet each other. Okay, so now when I unfold it, it can be a little bit difficult to see because of the light, but you'll see that they all meet at this point right here. It might be helpful if I say this point right here, all those folds meet. There we go. Folks, this is called your circumcenter, the circumcenter of a triangle. We've got multiple different centers of triangles. This is just one of them. So our circumcenter is created by perpendicular bisectors. And don't worry about writing that down right now. We'll do some notes at the end. Okay, let's talk about now what happens with a right triangle. So that was acute. We're going to do the same thing where we fold these guys over like that, just in half. All right, let's fold this side to this side, all right, in half. Oh, let's make sure you can see that. There we go. Give you a nice good crease there. And then it looks like I'm missing, nope, I got that side, I've got this side, I've got this side I'm missing. So fold that right here. Give it a good crease. Okay, so in our right triangle, to find our circumcenter, you'll see that it lands right on the triangle itself. So when we have a right triangle, it lands on the circumcenter lands right on the triangle. Again, we'll do some notes at the end, but I just want you to be able to visualize this. Okay, now we have an obtuse triangle. We're going to do the same thing again, and you'll notice I left a little bit of paper here, and I bet that's because you're predicting this one is going to be a little bit different. Let me start by folding these two over, and I snipped off the sides so that it made it easier to find the exact middle. But you'll see once I fold over these two sides that your prediction is it's going to be outside our triangle, because on our acute one, it is on the inside. On the right triangle, it is on the triangle, and on our obtuse one, you guessed it, it's right on the outside here. So let me fold this last little bit over. All right, so there we go. We match those up, get my 90-degree angle here. And sure enough, you can see that all of these folds come together at this point right about here. And so in our obtuse, when we have an obtuse triangle, our circumcenter meets out on the outside of that. Okay, so let's talk about some notes for this. Actually, before we even begin some notes, I do want to actually show you how we construct a circumcenter. So we're going to talk about how we construct this using a compass and a straight edge. In my case, my straight edge is going to be my little protractor here. All right, so here's what we do. We find our point, and so I'm going to start with BC here, BC. And what we do is we want to find a point that is further than the midway point. And we take our compass here, and I find it easier to move the paper as we do this. We're going to draw it like this. Perfect. Okay, so now what we're going to do is, notice I'm not moving the radius or the distance on my compass here, but I am putting it on point B. I did point C first, now I'm doing it point B. Okay. So what I've done here is create two intersecting points. And what I'm going to do is take my straight edge and I'm going to line those points up. And then, so there's those points right there. And then what I'm going to do is we're going to draw that all the way across. Bam. Just like that. Okay. And I'm doing it just in the triangle because this is an acute triangle. So now we're going to do AB here. Let's do AB. So for AB, I'm going to start on point A, and it only has to be a little bit more than halfway. So I don't want to go too far. So there we go. Draw my circle there, or my arc, I should say. And then do it again here. I cut off the corners of this paper just so it doesn't run into my camera while I'm recording this, so you can see it. Okay, I have two intersecting points, so I have done this correctly. So let's take my straight edge. Again, it doesn't have to be it doesn't have to be a protractor. And I find those 2 points there. And I say, all right. Actually, let me slide that up a little bit so you can see we got those 2 points right there. All right. There's that one. Now I've got to do the AC line. So let's do our AC, and we're going to do the same thing. Take this guy, and this one has to be more than halfway. And so we've got to be very careful about this, because if it's not, you're just going to have to redo it, and that's not fun. So, well, I think it's fun, but lots of kids don't. So I did it more than halfway there. Oops, and I messed up because I was talking about how fun math is. All right, there we go. Now I'm going to take this guy right here and do the same thing. You got to make the sound, otherwise it doesn't work. Okay. All right, so now for AC, I have 2 points that cross. So again, take my straight edge, find those 2 points right there, and I draw my line through that. And ta-da, look at, we have our circumcenter right here in our acute triangle right on the inside there. So that's how you construct it with a compass and a straight edge. Now it's time for some notes. So grab your notebook, let's talk about this. So perpendicular bisectors in triangles, they are the circumcenter is created by these perpendicular bisectors, as we've mentioned. As I mentioned before, right triangles, it's going to be on, acute triangles, it's going to be on the inside, and obtuse triangles, it's going to be on the outside. Okay, what is something else that is very neat about this? This theorem is important. Write this one down. The perpendicular bisectors of the sides of a triangle, so we take the sides, we cut them in half, we create a perpendicular line, are concurrent at a point equidistant from the vertices. So are concurrent at a point, think another way to word that is like they occur at a point equidistant from the vertices. Okay, so that's not something we've talked about. Here, I'm going to go back to my triangle here, and that says that they are equidistant from my vertices. So I'm going to take my green, and we're going to use my protractor. You can see the frantic look around as I'm trying to find it. So that means that if I go from this guy to right here, and then if I go from this guy to right here, the vertice to the center, the circumcenter, got to be very clear about that. Oh, and the green and the blue are a little too dark. That's okay, a little too different. And then from here to here, all of these points are going to be, or all of these line segments are going to be the same. So let me highlight that for you. If you go from that circumcenter and you shoot out towards the corners, those are all going to be the same length. That is an important part of our circumcenter. All right, friends, if you have questions, let your teacher know. Otherwise, we will see you next time.